So I thought I'd make a pretty simple video on how this program works. I apologize about the audio. It's not too great because it's just a laptop mic. I didn't feel like getting anything set up. Anyways, so the buttons are a little bit weird because of pfop.js. I don't know. Sometimes they register, sometimes they don't. I usually just double click things to make sure that they work. So when you press add, you can click on the canvas, it'll make vertices. When you want to delete a vertex, you just click it, press delete, deletes it. Any edges that are connected to it will be deleted as well. So when you want to add an edge, you usually just click one vertex, press new edge, and then click your other vertex and click new edge again. If you want to reset it, you can just click outside and press new edge, or you can just press any other buttons, but I don't like doing that. So in this case, I'm going to add a little bit more here, just to show the algorithm. Oops, that's not one. I don't know why I'm thinking so hard when I'm doing this. Oopsies. So once you have like a graph, like this one won't be even connected. It'll just have random, subgraphs in it. You can run the algorithm. Press that. You'll see that one pretty much highlights. The algorithm selects things randomly, so it's not going to select, like, it doesn't start with anything that you select. It's just, most vertices are random, just like the algorithm described in that one paper. So as you can see, you can just go to the next spots, or the next stages, sorry, and you can change the increment. So right now, my increment is on ×1. So in the next stage, this one gets burned, and then it selects a random one. And then this one gets burned, it selects a random one. Now, here's what I will say. The weird thing about this algorithm, I don't know if this is a bug. Like I said, this is in the prototype stage, so it's not completely done. The algorithm, it works at depth. So what happens is if you see in this one here, this bottom one, what happens is the first breadth first search, it's gonna go here and then here, right? And I'm assuming because this top one goes for so long that the minimum depth that it allowed was probably about 4. 1, 2, 3, 4, right? So what happens is when this one reaches an end, it just says, you know what, we're gonna pick a next random vertex to choose, which what happens is it ends up being this top one, and that's why you see it in round 2 it does that. But then this one, because the depth was actually allowed to go all the way, it doesn't say let's pick a random one after round 4, because it does, when it gets to the end, it does actually pick this one on the bottom on the 3rd round. But these all actually get selected during the breadth first search, and there's no like situation for picking a random vertex again. So you'll see that this actually is not the minimum, because in this case, what could have happened was after this I could have picked like this one next, and either way, like, it probably would have been faster. Actually, I could have picked this one at the top right here in this same round, and then these would have been gone. So this one's actually probably 1 round longer than the minimum. But again, it is an approximation algorithm, so it's not always going to get it right. It depends where you start with for the minimum rounds allowed and the increment. But yeah, you could also, for larger graphs, if you were to make any, you can skip steps. Like you can go by 5, right? This one doesn't even have enough rounds to really show it, but if you had a lot of vertices, you could do 20, you could do 50. Not that you would really want to make 100 or 200 vertices on these graphs, because like it's not a best, tool for making them. Of course, when I envisioned this, I envisioned it making it a lot easier. But it is what it is. At least the functionality is there, and if I ever want to carry over the code, it's there. So yeah, you will notice on some graphs, like I said, this algorithm kind of runs funny. It's just because it's a prototype. I haven't been able to put as much time as I wanted to. But it is what it is. And if you want to reach this, of course, it's at cmh.github.io. And there's also a GitHub repository that includes all the source code and documentation. So hopefully you enjoyed it. So yeah, have a good one.